In this video, we'll determine whether or not the alternating series, whose terms are of the form -1 to the n over n times the square root of n, converges absolutely, converges conditionally, or diverges. To do that, it's important to first realize that we're alternating the powers of n in the denominator, and if I take the expression n times the square root of n, I'm really looking at n times, or n to the 3/2, and I'm alternating those terms. When n is equal to 1, the first term will be negative, and I'll have 1, and then I'll have 1 over 2 to the 3/2 minus 1 over 3 to the 3/2, etc. What we'll do is we'll check for absolute convergence. So I'm going to take my series, and I'm going to take the absolute value of each individual term. In practice, that means just ignoring the sign that we're alternating from term to term, and so I'll just be looking at 1 over n to the 3/2. This is a p-series. The power is 3/2, and because that power is bigger than 1, the terms are going to 0 fast enough to ensure that the positive series converges by the p-series test. As a consequence, my original alternating series converges absolutely, and we've answered the question. It's worth noting here that the original series that I started with, which I'm alternating, could have been shown to converge by the alternating series test, so in fact that does apply, but it wasn't necessary to use the alternating series test here. It's a consequence of the absolute convergence test that if my series converges absolutely, which I showed above, that my original series must also converge. So the fact that this series with the absolute value of each term converges ensures that the alternating series also converges, and it wasn't necessary to check that individually.